I'm going to try to keep this demo under 10 minutes. This demo illustrates the use of various command line tools or Unix utilities. Instead of executing these commands in a terminal, this is a terminal here. It's a little nicer to do it where we're going to be working in a Python notebook, Jupyter notebook, pardon me, because you can weave together your command line codes with text and images and visuals. It's just a nicer place maybe for presentation. It requires wrapping your commands up in a function, though, made possible by the subprocess module, and that function is called Shay. You can call it anything, but I used Shay. The data we're going to be working with has 10 lines. It's all the cats that we've owned. The cat command happens to be a command that says, show me the contents of a file. Just to go back to the terminal real quick. We are in the felines folder, and there are several files in the felines folder. The second one's called cats. One of the nice things about using the terminal is you can bring up previously used commands. Right now I'm just arrowing through them. And there's cat space cats.txt. There's our 10 lines. But we're not going to use the terminal. Okay, let's go to the first command. It's the column command. It provides a nicer way of seeing the data. It puts it in a tabular format. You just have to tell the column command what your field separator is. That's a little prettier than the one up here, but because we only have 3 columns, it's not imperative that we have things nice and pretty. I'm not going to be using the column command the rest of the way, but I just wanted to introduce you to it. The second command, so that pipe symbol, by the way, is a way in which you execute a command and then send the output of that command onto another command where it's the input of that second command. The pipe symbol is wonderful, and you can use many pipe symbols. You could have 3 different or 4 different, as many commands as you want separated by pipes. Here we just have 2. That second command is sed, or string editor. Sed does all sorts of neat things, but here it's just going to print out, it's going to allow us to print out the 3rd through 7th lines of our cats file. So we don't see Sunset, we don't see Fluffy, and we don't see any of our cats that we got after Shelly. And we're not matching on a pattern, which is often the case. We're just explicitly saying, show me these particular numeric lines. Here we're going to match on a pattern. And let's see. Although here we're still going to return all 10 lines, I think. But what does the substitution do? The substitution command within sed. It says find the lines that have an S asterisk tink. The asterisk means 0 or more occurrences of the character prior to the asterisk. So it doesn't mandatorily require that there be an S, but there could be. Followed by tink, and then substitute the LL with LLY. Let's run this. There's 2 blocks that get output, one for each of the commands. First, we're going to focus on the first one. That was redundant. It only changed the LL in Tinkerbell to LLY. We don't have... Stonewall didn't get changed. If Stonewall's name was Stinkwall or Tinkwall, it would say Stinkwally or Tinkwally. But it only changed or only matched on Tinkerbell. The next one's tricky because I've introduced this not operator. The exclamation point serves to negate the criteria. So in this case, and that's a character set that you see in brackets. Don't worry about it. This is what it means, though. If you find an S, a T, or a Y on a particular line, I want you to change the A or the E to an ampersand. That's what this command is saying. But because we've negated the substitute, it says Only change the A or an E to an ampersand if there's not an S, T, or Y on the line. That's why Pauly and Shay, who don't have an S, T, or Y in there, that's why they were changed, but the others weren't. If I remove the exclamation point, now it's not going to change Pauly and Shay, but it's going to change the other ones. Make sense? It changed all of these that have S, T, or Y. Fluffy didn't get changed because Fluffy doesn't have an A or an E to change to an ampersand. So that's why Fluffy looks the same. I'm going to undo, or I'm sorry, I'm going to put back the exclamation point. And we're going to move on to the next one. This says, match lines where there's an A or an E followed by any two characters. That's what the dot dot means here. And then the next character has to be an I or a Y. The second command we'll talk about in a minute. Okay, let's look at the first block. Those are the only lines in which there is an A or an E followed by any two characters followed by an I or a Y. Could we negate? Now we're not negating the substitute, we're negating the P for print. Same thing though. This first block that I do, and once I execute this, my first block should now have 6 cats, all the ones that don't satisfy the criteria. And it does. You undo the exclamation point, and the second one says, find all the lines with A, I, O, or U, and don't print them. So print the ones that don't have A, I, O, or U. Petey, Shelly, and Shay are the only cats that we've owned that don't have any vowels except the E. Make sense? This is really cool because when you're searching a database and you use SQL, I don't know how you would tell it to find lines to match on a particular line, but then don't give me that line. Give me the one before or after it. There's ways of doing it, but none are as succinct as what you can do here. None can be written as succinctly. And that's really the greater advantage to all these command line utilities. They're just really clever, short ways of expressing what you want to get. So this first one says, find the lines that have Uffy in them and give me the line after it, but don't give me the line with Uffy. So we got the one line after Fluffy. It's Tinkerbell. If I said, show me the line after Affy, it's not going to find anything. If I said, show me the line before Addie, it doesn't work. I don't know why, and we're not going to move. Why did it do that? Oh, that's a lot where there's no lines after Addie. Addie's the last cat. Okay, I'm going to change this back to Uffy. And, okay, now we're going to do before. And I agree that the notation here is weird. I don't know why you have to have all that mumbo jumbo, but this is going to give us the line before the line that contains Uffy. That's why we got Sunset. Now we're going to do Addie. Match on any line that contains Addie and give me the one before it. Shay. That was beautiful. Our cats are listed in chronological order in case you haven't figured that out. Okay. Let's go on to number 7. This is going to... It's not so much that it's matching. Well, it's a delete command, which is kind of the inverse of matching. This is going to return all the lines between Petey and Pauly, and also it's not going to return the lines containing Petey or Pauly. So yeah, this works. We got everything before Petey and all the cats after Pauly. So we got 5. And if we wanted to see the inverse and we put the negation in front of the delete, we should now get cats 4 through 8. And we do. It did exactly what we wanted. If only my dealings with people were so predictable. Number 8. we're going to delete the numeric range. Here we're not matching on any criteria. We're explicitly indicating the index of our lines. This is going to remove 4 through 9, so it should give us 1 through 3 and 10. So it should give us Fluffy, or Sunset Fluffy, Tinkerbell, and Addie. Sunset Fluffy, Tinkerbell, and Addie. Beautiful. So all these combinations of different things that you can do, and sometimes there's many ways to do them. There's many ways to skin the cat. But memorizing them all and kind of knowing which ones are the easiest to use in certain situations, that's the whole trick to kind of becoming a master in using these various tools. We're almost done because I think I'm going to stop at 11. So we have 3 more to go. This one's a little tricky. We're using the said substitution, but we can indicate which instance of a match gets substituted. The first command, there's no number indicated after the last slash, so it assumes that we only want to change the first instance. And I'm going to comment out I commented out the second and third commands. We're only going to look at the one. This found the first S and it changed it to a 5. Makes sense? Now, the concept of matching doesn't apply here. When you do a find and replace in a Word document, you're not just going to see the items that got replaced. You still see the whole document. Same thing here. That's why Shay, in spite of not having S's, still shows up. Where are the rest of the cats? We're no longer working on the cats.txt file. Look after the cat command. We're looking on a specific file that just has all the male cats. So that's why Shay is still in scope, even if Shay isn't impacted by the find and replace, by virtue of not having an S in her name, his name. When we first got Shay, I didn't know what gender he was. It's kind of funny. This one is going to replace the third O with a 0. None of the lines have 3 O's except the line with smush. Thus, we only saw that one change. Now we're going to go back to using S's, substituting S's, and we're going to change our S's to 5s, but we're going to do it globally. So it's going to change all the S's. Sunset, both S's got changed. Both S's in Smush, the one in Stonewall. We still have Shay hanging around with the boys. Okay, let's go to the 10th one. 10th and 11th. Sometimes you want to insert a pattern at the beginning of each line, and this hat there, which is above the 6 on your keyboard, that tells it to do it at the beginning of the line. Find every line and add 3 dots and a few spaces to the beginning. Okay, makes sense. We also can do it at the end of the line. $sign. So $sign's the end, and all sorts of things that you'll do with command line utilities. The $sign means the end of the line. The hat means the beginning. Now you'll see that it added 3 dots and a bunch of spaces to the end of the line. While we're here, I'm going to show that. I'm going to pipe this to head. Okay. The head and the tail command are ways of further narrowing the set of data to just the top 3 is the head, the last 3, or you use tail if you wanted to see the end of a data set. And hey, if I change that head to 6, now we get as many as 6 lines. So this idea of the pipe, it's really cool. And in fact, I'm going to pipe it to cut command with the character flag, and this is going to give us 3 through 6. And see what it just did? When I piped it to cut in the character command, it knew to start with the 3rd character and to go through the 6th. You can, once you memorize all these different things, you can cut and slice and dice and Just don't do it with real cats. Let me remove that and go back to, and put the hat back on. Number 11. This is just it's a variation on the word count flag, or the word count command with an L flag for line. This gives us 10. It's a nice way of counting a data set when you're working with a huge data set and you want to get your control totals, as any good accountant sometimes needs to do when they're working with a huge data set. Yeah, SED has a way of doing it, but it's a variant on, let me just copy. Alternatively, I could have done word count. It gives me the 10. Without the line flag, it's going to give me 10, 10, and 111. That is 10 lines, 10 bytes, and it's 111 characters. So word count actually tells you 3 things, but most commonly you will be using word count to count lines. If you're counting the number of bytes or characters, like, I don't know, you're weird. It's just a less common use case. We're done with the first 11, and I think that's a good stopping point, but hope this made sense. You can obviously pause the video at any point, or slow it down, or speed it up if you're bored to death. I should have told you that at the beginning. Thanks for watching.